And finally, we're off and running. Okay, negation, that was easy, just the opposite. Um, and now, oh, and this one. How did this rule go? True only when they're different? Cool. Okay, here are the two we're going to talk about today. They are called the conditional and the biconditional. Conditional has a symbol that looks like this. It's got an arrow going to the right. And it basically stands for, in logic, if something over here, then, you know, like, if you get a GPA of at least 3.5, then you will be, I don't know, on the honor roll or whatever. If you continue in my word, then you are my disciples indeed. That's a Bible passage. The Bible uses if-thens all the time. Okay. Then we're going to do the biconditional, which is a double-headed arrow. So I got more hand signals for you today. Okay. So here we go with the if-then. Yeah, I don't know. I'll tell you what, I really think the symbols are important, and that's why I'm doing that. Now, I shouldn't really have shown it to you ahead of time, but there it is. So let me just tell you how. Here's what I normally do before I show that to you. I make up a statement like, if you do extra credit and put it in your table of contents, then I will correct it. Okay, there's an if-then statement. What would it take for that to be a lie? Okay, I make this promise to you. I say, if you do extra credit and you tell me about it in your table of contents, then I will correct it and award a certain number of points. Okay, what would it take for that to be a lie?
If you do not correct it when you do your standards.
Yeah, so if the if part, you guys follow through on, and if I don't follow through on the then part, then I'm a liar, right? So isn't that basically a promise? If you do this, then I will do, you know. So what's the one time an if-then statement is false? When the first part is true and the second part is false. And you notice that's the only line on there. Now, this one you're probably wondering about. Okay, let me just explain. Well, first of all, do you notice how there's only one line that's false? Okay. But I want to explain these others, especially these bottom two. You know, the top one, the scenario is you guys do the extra credit and you put it in your table of contents and I correct it and everyone is happy, right? Everything turned out just the way we said. Okay, in this line, this is the lie. You guys did the extra credit, you put it in your table of contents and I blew it. I lied to you. Bad boy. Okay? This line, you guys did not do your table of contents, you didn't do your extra credit, and somehow I corrected it anyway. Did I lie to you? No. I mean, I never said anything about if you didn't, right? And how about on this one? You didn't do your extra credit, you didn't put it in the table of contents, and I didn't correct it. Did I lie to you? No. So even though this looks terrible down here, FF yielding a T, do you see why it's a true? So the only time an if-then statement is false is when the first guy is true and the second guy is false. First is true, second is false. That's the only bad boy out of the four. And so I can't give you a shorter one than that. So I wrote down only false when the first statement's true and the second statement's false. Sorry, I can't get it any shorter than that. Okay? And then comes the biconditional. And that's a double-headed arrow. And really what it means is if P then Q, and if Q then P. It's really a dual You can probably tell that. That's why it's got a arrowhead on both sides. In fact, I think I should demonstrate that for you. But before we go on, let's just get it. This one is only true when both are alike. So, notice when we have a true and a true, it's true. And when we have a false and a false, it's true. But when they're different, it's false. Does that remind you of another rule? The exclusive or that like you had told me earlier, isn't that just the opposite of that? The exclusive or was only true when they're different. This one is only true when you're the same. And that's exactly right. That's why I wrote this on the bottom. The biconditional is the negation of the exclusive or. It's exactly the opposite results. And maybe not a bad way to remember it. So, now I should demonstrate this to you and then we'll practice our rules. So, in effect, what I have told you, we'll make a new one here. And I should really pull a grid up here. Man, nothing's going right today. Yeah, one cell. Yeah, oh well, we'll just do it without. Okay, so anyway, the statement that we're new to right now is this one. And I'm telling you that's equivalent to, if P then Q, ANDed with, if Q then P. And I want to show you that those two come out the same. Now, please don't be confused. Do you remember this symbol from last time? The equal sign with a couple of these on it means is equivalent to. And when do we know when two things are equivalent? When their truth tables come out exactly the same. Whereas this thing, just this one over here, you notice it just has a single horizontal bar? Please, you got to be able to tell it. So this is equivalent to, this is the biconditional. They're not the same. Okay, how did we say this comes out? I just gave it to you. Only true when they're alike. So let me fill that in. True, false, true, false. Only true when they're alike. Okay, now let's show that this other side comes out the same way. Okay, we got to use a new one today. This guy. Remember what the rule is? I just gave it to you a few minutes ago. Only false when the first is true and the second is false. Okay, PQ. They're both true. There's the bad boy when the first is true and the second is false. Here, the first is not true, so it can't be false. Okay, now, let's see if you can do it backwards. Again, rule. Only false when the first is true and the second is false. True, true. I got to do QP. That's true. False, true. That's true. True, false. There's the bad boy. And false, false. Only false when the first is so. Okay, there we go. Now, finally, what is the conjunction or and between those two? Now we got to go back to a previous rule. What is this rule? Only true when both are true. True, true. False, true. True, false. True, true. You notice how these two columns truly are identical? Therefore, hey, they really are equivalent.
Okay, so I don't know, maybe I shouldn't have done that yet, but I did, so. Okay. And that's the one I just did for you. And it looks like I did it here too. And here it is again. I guess I had it so many times. Okay. Let's do this one, but let me do a little erasing so we can simulate this for real again. So, here's this is on page 132, and actually this turns out to be a pretty important statement. You're supposed to take this guy right here and show that they really are equivalent. And you know what that means. It means I got to show the two truth tables come out the same. Okay? So, I started setting up the table. Good news, how many letters do I have? I still only have 2 letters, P and Q. That means I only need 2 to the 2 power rows. 4. Cool. So I set up 4 rows. Typical setup, P, 2 truths, 2 false. Q, go by ones, TF, TF. I'm going to need a not P, so the book doesn't always do this, but I like to throw in a not column if I need it. And I see I need one right over here, so I'm putting it in there. Okay, let's do the left side. If P, then Q. That's a new one. I just gave it to you today. The rule is only false when the first is true and the second is false. TT, TF, FT, FF. So there's my left side. All right, now I need to take this column. I need to do not P or Q. So this guy ORed with this guy. See that? I got to take my not P and my Q column and do the OR. And what's the rule for OR? I keep verbalizing these because this is what you got to do. You got to keep hammering on them. This one is what? False only when they're both false. Okay, here we go. True, false. They're not both false. Here they're both false. Nope, they're not both false. Nope, they're not both false. Ta-da! Do you notice how these 2 columns end with the same result? We've done it. We have shown that those 2 statements are equivalent. You're going to have some assignment problems of that type where they'll say, show me that these 2 are equivalent. This is the way you do it. You set up a truth table where you figure out both, and you show that the 2 columns really are identical. Okay. This is a little different, but it's very similar. I'll tell you what, I'm going to pick some up from the book. And let's do a few more. Well, I'm just trying to see. I guess let's start in the beginning here. Oh yeah, I wanted to show you one like this. Number 4. Would everybody please look at number 4? It says in problems 4 to 7, find the truth value of each statement. Number 4, if 2 plus 2 equals 22, then 22 equals 4. That's a true statement. And you're probably going, what? Here's why. Isn't the first part, the if part, false? Right? 2 plus 2 is not 22. I'm not going to get any argument on that, right? Okay? Now look on this table. If P is false, what do you notice about the conclusion? It's ironic, but if the first part of an if-then statement is false, you're guaranteed to be true. You see that? It's kind of like the one I always use. I often use this one. I say to my wife, "If I get out of work before 5 o'clock, then I will go buy a loaf of bread." Okay. So the false in the beginning is I didn't get out of work at 5 o'clock. And so, am I not out of my promise now? You know, if the if part isn't true, it's kind of like I got out of my promise. And if if I don't get bread, I didn't do anything bad. If I do get bread, I did some extra credit. And I certainly I even did more than I would promised I would do, right? So you see how, it sounds silly, but when the if part of the if-then is false, it's guaranteed to be okay. I'm sure you've heard this occasionally when people are trying to make their point, they'll say, yeah, when hell freezes over. So like, in effect, what they're saying is if hell freezes over, then I'll get an A in this class. Okay, and you're pretty safe because hell is not going to be freezing over. Okay, and so that's just kind of a safe way to be humorous. Okay, or yeah, sure, that'll happen when pigs fly. You probably have heard that one, and it's the same deal. It's like, if pigs fly, then I will, give everyone $1, and of course you better define that because, yes, pigs can be in the back of an airplane when an airplane flies, and I suppose then a pig can fly. But you get my idea. Last I checked, they haven't been flying by flapping their ears or something like that. Okay. So, okay, point made. Let's do number 18. Construct a truth table. Number 18 says, if P then Q, and you're supposed to take that statement and it with if P then R. Okay. Well, the first problem we have is, for the first time, I think, we have 3 letters. Uh-oh. Now we got to use 2 to the 3rd power. We need 8 rows. Do you see that? So, we need a P, a Q, and an R. And we need 8 rows. So, my P column is going to be half and half, 4 trues, 4 falses. And then I'm going to go by 2s with my Qs. 2 TT, FF, TT, FF. And then when I do my R, now I'm going to go in the single mode, TF, TF. Again, that technique will guarantee that you will get all 8 possible outcomes. So that's unique. I think we maybe did one more 3 one before. Okay, if P then Q. New rule. What is it? Only false when the first one's true and the second one's false. TT, TT, TF. There's the bad boy. There's another bad boy. TF. False true, false true, false false, false false. Now we got to do if P then R. So we got to use these 2 columns. So you got to, what I do is I'm doing these on my paper. I actually put my fingers on the 2 columns that I'm doing so I don't get mixed up. It sounds corny, but it's so easy to look at the wrong column. So I'm doing like this now, and I'm doing the same rule. If only false when the first is true and the second is false.
That's going to be a true. That's going to be a false. A true. A false. A true. A true. A true. A true. So let's just write those out now. P and R, if P then R. True, true. True, false. True, true. True, false. False, true. False, false. False, true. False, false. Okay. And then what's the last step? We need to take those two columns and them. And that rule is only true when both are true. True, true. True, false. False, true. False, false. Here's another good one. True, true. True, true. True, true. True, true. And that, the style that I did it in, that would be our final result. Does that make sense? Okay. Let's see. Let's find another one to do. See, there aren't that many constructive truth table ones here, are there? Okay, let's do something with words. I was just looking at some of these, and they say in problems 35 to 39, let's see, I got to read the directions. The statement, all even numbers are divisible by 2, can be translated this way. If it's an even number, then it's divisible by 2. So, using that idea, do numbers 35 to 39 and write each statement in if-then form. So, 36, all cats are felines. What's the if-then way to say all cats are felines? Isn't it, if it's a cat, then it's a feline? And if we were using symbolism, we'd probably just say, if it's a cat, then it's feline. So let me just go through another one. All people in this room, forgive me for my terrible examples, okay? All people in this room are breathing. Then if-then form is, if you're a person in this room, then you are breathing. So what you're going to find is, we're going to have to translate statements a little bit like that sometimes. So when we get an all statement, we're going to rewrite it in an if-then form. Okay, that was what number? 36? How about 29 to 31? Write each statement in symbolic form using not and or. Also write the corresponding statement in words. And they give you a hint. If P then Q is equivalent to, I think we just did this one, didn't we? If P then Q is equivalent to not P or Q. Okay, so let's do, I don't know, 30. If Mida is home by 5, H, number is this 30. If Mida is home by 5, then dinner will be ready by 6. Now, that's fine, except the book said they wanted the answer only to have these two symbols. And I don't see those at all. But use this. Can't we use this model to rewrite this?
If P then Q is the same as not P or Q, so then what's the same as if H then R? Yes? You see how I use that model? You guys are awfully quiet. It only worries me that you're like numb and you're not getting what I'm saying, and maybe it's because I'm not being clear or something, I don't know. This, by the way, this one that they gave us for a given there, this is going to come in handy. You're going to see this one over and over. So that's what? That's an equivalence that's worth remembering, maybe highlighting in your notebooks. It's going to keep coming up, not just in this section, but in other sections. When you need to put things in or notation. Actually, the last lesson of the chapter, I know we're going to need to do that too. So I'll be reminding you of it. Okay, the only thing left to do, I guess, is to name the assignment, and I'm going to have to look online to do that. Did anybody look it up already? One, 3, 5. So every other odd from 1 to 57. Actually, I don't know if 57 is the last one. It might be 55, it might be 57. Whatever, if you keep following that pattern, do 1. I'm sorry, that's every odd, isn't it? 1 to 57, the odds. We're done a little early, and you guys can go.